Hello students, so welcome to my new video with one more topic. So today we are going to discuss a topic from class 11 from the chapter of friction. Now those who have not seen my previous video on free body diagrams, I request you to please go and see the free body diagrams from that video. Now over there we have discussed that if a block is placed on a smooth inclined plane, okay, smooth inclined plane means where we have not considered friction. So if we place a block on a smooth inclined plane, then what is going to be the acceleration of the block down the inclined plane, okay? So if a block is placed on a smooth inclined plane, then the block is going to slide down with an acceleration, and what will be the acceleration we have seen in that video. Today we are going to see the acceleration of a block down a rough inclined plane. That means an inclined plane which has friction on it. Okay, so if the inclined plane is having a friction on it, then what is going to be the acceleration of the block down the inclined plane? Okay, so let's start. So today's topic of discussion is expression for the acceleration of a block down a rough inclined plane. Fine. So suppose this is an inclined plane. This is an inclined plane. Okay. Now this is the angle of the inclined plane. This one is the angle of the inclined plane, okay, and a block is placed over here. This is the block which is placed over here. Okay. Now before starting this, let us first discuss about this angle. Now this particular angle is known as the angle of repose. Okay. Now what is actually angle of repose? Here I am writing theta r equals to angle of repose. Okay. Now what is angle of repose in a friction or in an inclined plane? Now see students, if we have an inclined plane, which is rough, that means which has a particular friction. So this is an inclined plane. This is the particular value of the angle of the inclined plane. Okay. Now this is a rough inclined plane, that means it has friction on it. And if I place a block over here, okay, if I place a block over here, now for any angle of inclination of the inclined plane, the block will not just simply slide down, because the block is placed over here. The block has a tendency to move along this component, okay, to move along this direction. You know that if this is mg, if this one is mg, okay, this will also be theta, this is mg cos theta, and this is mg sin theta. This is mg sin theta, okay. So this one already I have explained in my previous video. Now, and on the opposite side of mg cos theta there is r, there is the reaction force, okay. Now this mg cos theta tries to bring the block down the inclined plane, okay. But remember, in this particular figure, in this sort of plane, there is also friction present. So friction is going to act in this direction, static friction. Okay. Now you see, friction always tries to keep two bodies together. Okay. Friction always tries to keep two bodies together, and remember, friction is an adjusting force. That means friction, okay, if you increase the external force, friction can also increase up to a certain level. Now when the body tries to slide down mg sin theta, friction is going to stop the body from sliding down. Okay. Friction is going to stop it, because friction always wants that the body and this particular surface, they are together. Okay, so friction always wants them to be together. So the friction will always try to stop the relative motion between the block and the surface or the inclined plane. Okay. Now, so initially, for whatever angle of inclination of the inclined plane, the block is not just going to easily slide down. Fine. But what is going to happen if I increase the value of theta? Okay, so suppose if I am increasing the value of theta, so suppose theta was this one, okay, some friction is acting on this side, but suppose if I increase the value of theta, okay, now if I increase the value of theta, you see this particular component mg sin theta, this particular component is also going to increase. Okay, so this particular component is also going to increase. Now as I say that friction is a self-adjusting force. Okay, friction is a self-adjusting force. So when friction, will see that the downward force the downward force which is acting has increased, friction is also going to increase. Okay, so again the block will not start to slide down. Now if I increase the angle more, so this mg sin theta component more it is going to increase, so friction is also going to increase. Now suppose if I continue this process, I am continuously slowly very slowly, suppose if I am increasing this particular angle of inclination, okay, so when I am increasing the angle of inclination, the block is not yet sliding down. Why? Because friction is stopping the block from sliding down, because as the component mg sin theta is increasing, friction is also increasing, because friction is a self-adjusting force. Okay, so this component is increasing, friction is also increasing, this component is increasing, friction is also increasing, but a certain time is going to come when friction will reach its maximum value. You know, friction has a maximum value which is given by, the maximum value of friction is given by mu s into r. This is the maximum value of friction. This is the maximum value of friction. Okay, this is the maximum frictional force which friction can apply. Fine. Now suppose at that point of time still the body is not sliding down, still the body is stopped by this frictional force. Okay, but if I increase the angle more of the inclination of the inclined plane, if I increase the angle more, the inclination of the inclined plane, then the block is going to start sliding down with an acceleration, because in that case friction can no longer stop the body. Until now friction was stopping the body, because I was increasing the angle of inclination, mg sin theta component was increasing and friction was stopping the body. Friction was also increasing. Okay, so mg sin theta component was also increasing, friction was also increasing, so friction was stopping the body. Fine. But at a certain angle of incidence, at a certain angle of inclination, okay, at a certain angle of inclination, when the block will just begin to slide down, okay, because when I am increasing the angle of inclination, a certain time will come when mg sin theta component will become greater than the frictional force. Frictional force cannot increase up after a certain level, so mg sin theta component is going to cross that certain level. Okay, so at that point of time the block is going to slide down. Right? So that particular angle for which the block starts to slide down is known as the angle of repose. Okay, I hope you understood what is angle of repose. This is very important to understand this particular derivation, angle of repose. So angle of repose is that angle of inclination of the inclined plane for which the body just starts to slide down. Okay, it just starts to slide down with an acceleration. That particular angle is known as the angle of repose. Fine. Now I think you can understand, if the angle of inclination is less than the angle of repose, if the angle of inclination is less than the angle of repose, then the block is not going to slide down, because friction is going to stop the body from sliding down. But if the angle of repose is greater than, that means if the angle of inclination is greater than the angle of repose, in that case the block is going to slide down. Or we can say that at the angle of repose, the block will start to slide down with an acceleration. Okay, now let's see over here. So this particular angle over here I have considered to be the angle of repose. That means at this particular angle the block has started to slide down. Okay, the block has started to slide down. There is friction, but friction has reached its maximum value. Friction can increase no more. So friction said that, okay, no matter what, I cannot increase after this particular level. If you want to slide down, you go. Okay, so friction has increased its maximum value at this particular point. So we are actually going to find out the acceleration of the block. What is going to be the acceleration of the block, that we are going to find out. Okay, so first let us see what are the forces that are acting on the body. So as you all know, this will be mg. If this is theta r, this angle also will be theta r. So this is mg cos theta r. This is mg sin theta r. This is r. Remember, over here there is also this frictional force which is acting. This frictional force also it is acting. Okay, I am giving it limiting friction. Limiting friction, in some books you will get static friction also, but I am over here I am giving limiting friction. Why limiting friction? Because limiting friction is a friction which acts when a body just begins to move. That's why I have given a limiting friction. Okay, so these are the forces that are acting on the body. Fine. So remember this theta r is the angle of repose. Okay, theta r is the angle of repose. Okay, so the block is moving down with a constant acceleration. So what is going to happen at equilibrium? At equilibrium. Okay. So these are the vertical components. These are the vertical forces. Okay. So in the vertical direction. So this R is going to balance this mg cos theta. Okay. So vertical direction R will balance this mg cos theta. Fine. Okay. Now along the plane. Now I have shown you in the free body diagram how to calculate when more than one force is acting on a body. Okay, in that case. Now see, over here in this particular body, mg sin theta is acting in this direction and friction is acting in this direction. Okay, mg sin theta is acting in this direction, friction is acting in this direction. Which force is greater? Which force is greater? I said that up to the point when friction will be equal to this particular component, until that time the body is not going to move. Okay, the body is not going to move because that is the maximum value of friction which it can apply on the body or on the surface. But if I increase the angle of inclination more, which is equal to the angle of repose, then this particular component, this particular force mg sin theta is going to become more than the frictional force. That is why the block is sliding down in this direction. Okay, you have to understand why the block is sliding down in this particular direction. You have to understand the concept. Why the block is sliding down in this particular direction? Because this force is greater than this force. Okay, this force is greater than this force. If this force is equal to this force, then the block is not going to slide down. The block is going to remain over there. But now this force is greater than this force because I have increased the angle of inclination so much, okay, which I have made it equal to the angle of repose, that this force becomes greater than the frictional force. Okay. So obviously mg sin theta, the resultant force that will be acting on the body is mg sin theta minus Fk or Fs. Okay. So mg sin theta minus Fs. That will be equals to mass into acceleration. Okay, that is equals to mass into acceleration. Right. Okay. So from here, suppose this is equation 2. Okay, this one is equation 2. Okay. Now mg sin theta minus friction. Now you see, what is friction? Friction is basically this particular formula. Frictional force is equal to mu into r. That is the frictional force. That is the maximum value of friction. Okay. So mu L into r. That is the frictional force, which is equal to m. Fine. Okay. So mg sin theta minus mu L. Okay. Into r. What is r? R is mg cos theta which is equals to mass into acceleration. Fine. So you can see from both the sides mm will be cancelled, so we can get a equals to g sin theta minus mu L cos theta. In some of the books, you can find this to be written with K also, kinetic friction. Okay, so this will be the value of acceleration of the body. G sin theta minus mu K cos theta or mu L cos theta. Okay, so in this particular acceleration, the body is going to slide down. So that was the expression for acceleration. Now, one special case. Suppose the inclined plane is designed in such a way. Okay, suppose the inclined plane is designed in such a way. Oh, one more thing over here, g sin theta. over here there will be 1 g. So I can take g common. Now suppose the inclined plane is designed in such a way that the block moves down but there is no acceleration. That means the block moves down with a constant velocity. Suppose the inclined plane is designed in a particular way. So if the block moves down with a constant velocity. So if the block moves down with a constant velocity, that means suppose if there is no acceleration and the block is sliding down with a constant velocity, in that case you see what is going to happen. So acceleration is 0 because the velocity is constant. So we can write g sin theta r minus mu k cos theta r, that is equals to 0. So therefore sin theta r will be equals to mu k cos theta. Oh, I have taken L, so mu L cos theta. Okay, so from here I can write mu L will be sin theta by cos theta, that is tan theta. So mu L is going to be tan theta. This is going to be the expression. Okay, so if the block moves down with a constant velocity. So this is how we can calculate the acceleration of a block down an inclined plane which is rough, that means which has a particular friction on it. I hope you liked the video. If you like the video, please like and subscribe. Thank you.